Hey, this is a video for 3.8, Human Population Dynamics. So go ahead and check out the overview and set up your guided notes. So globally, the population density is different in different parts of the world. As to be expected, the population density is low in Canada and Russia just because of the climate that is present there. Also, much of Australia is a desert, and the Sahara Desert also has a low population density. Now, areas where the population density is high are European countries, India, Pakistan, Bangladesh, Japan, Korea. A lot of Asia, it has high population density. The country with the highest population total is India, which recently overtook China. China's second, United States is third, and we're coming into like Indonesia, Brazil, Pakistan, Nigeria are all like rounding out the top five. You want to consult the latest data if you really do question what it is currently, because it changes. Honestly, it's been changing over the last couple of years. Every year it's a different country in like fourth or fifth place. Now, Thomas Malthus was a population demographer. He studied populations, and he noted that the human population shows biotic potential and it will continue to grow exponentially. However, food production grows arithmetically. So there's going to be a certain point in which our population exceeds the food production. And at this point, we will have a crisis. So it begs the question, what is the Earth's carrying capacity? Different scientists have different opinions. Some say it's as low as 9 billion. Some say it's upwards of 12 billion. Now, we won't really know until we reach this crisis, but right now we do have the ability to feed a large portion of the population. Much of the reason why people are going hungry and starving is not because of inability to produce food. It's because of government issues. So we have some governments that are not so they're not so kind to their citizens. Let's just put it that way. So calculating population increases. I'm going to give you the formula that we had in the past. This is the inputs. These are the outputs over the total population. But another one you might see is where it's called rate of natural increase. And the reason it's rate of natural increase is because it's just from births and deaths. It can also be called percent growth. So you might see it written either way. Both could be used synonymously, even though they don't technically mean the same thing. The crude birth rate is the number of births per 1,000. The death rate per population, per 1,000 population. The crude death rate is the number of deaths per 1,000 people. So the reason it's 1,000, the reason we're dividing by 10 is when you take 1,000 and divide by 10, you get 100, which is the same thing as percent. So the bonus of this question is you don't actually have to multiply by 100. And in fact, some of the multiple choice questions might have an option in there to try to trick you, so don't fall for it. Memorize this equation. Actually, you got to memorize all of the equations in this unit. So let's look at a question. In 2020, the United States had a crude birth rate of 12 per 1,000 and a crude death rate of 9 per 1,000. Calculate the percent growth for the U.S. in 2020. Let's go through and annotate. 12 per 1,000 is the crude birth rate. 9 per 1,000 is the crude death rate. And percent growth is our unknown. So let's go ahead and substitute. We got 12 minus 9 equals x. Or 12 minus 9 divided by 10 equals x. When we substitute, we get 3 divided by 10. Again, we are not multiplying by 100. So the answer is 0.3%. Let's look at another question. In 2020, Canada's RNI, by the way, rate of natural increase, was 0.2%. If Canada's crude birth rate was 10 per 1,000, calculate the crude death rate of Canada in 2020. So let's plug in our numbers. Let's annotate. RNI was 0.2. Crude birth rate was 10. And the crude death rate is actually unknown. So let's plug in our numbers. We have 0.2 equals 10 minus x over 10. When we solve for this, I'm just going to go ahead and multiply both sides by 10 to get rid of that denominator because I don't like that. So 2 equals 10 minus x. 2 equals 10 minus 8. X is 8. We don't do anything further because there is no multiplying by 100. So the answer for the crude death rate is 8. Now, calculating doubling time. The formula is slightly different. Doubling time equals 70 divided by percent growth. You're literally just plugging in the number for percent growth. You are not changing percent. You're not multiplying or dividing by 100, so do not be confused by that. So the doubling time is going to be in years. And this is an approximation. And there's actually, doesn't have to do with just populations. It can have to do with, like, I think it was a financial analyst that actually came up with this formula. So I don't know the full details about it, but it's approximately 70. So it's like 69.6 or 8 or something, but close enough to 70. So we call this the rule of 70. Let's look at a question. Calculate the doubling time of Canada in 2020. Well, we did know the percent growth. We need to calculate the doubling time. That is our unknown. The percent growth we were given in the past. That was from the other question. That was 0.2. So what you're doing is literally taking 70 divided by 0.2. When you do that, that equals x, and it is 350 years. We're going to do another one. Calculate the doubling time of the United States in 2020. And that was one of the questions that we had calculated earlier. So the doubling time percent growth is the same thing. The percent growth was 0.3 in the United States. So to calculate the doubling time, it's 70 divided by 0.3. That equals x, and it's 233 years. So standard of living is something that is really indicating what a population is going to look like in a particular country. It's going to indicate the growth rate. It's going to indicate the crude birth, crude death rate. It's going to indicate infant mortality, total fertility. It's going to have an influence on all of those. So the standard of living is indicated by wealth. In other words, a country with a strong economy will have a high standard of living. And this GDP, you might see that written, it means gross domestic product. It's basically a total of all the goods and services produced by that country. We also have necessities. So if they have more complete infrastructure, you're able to provide more necessities for these people. Things like food, water, and shelter. Now, there's also some comforts, and comforts is something that a resident can afford. It's not something that's necessarily required in order to survive. Things like that could be entertainment and other comforts. You know, like maybe you have air conditioning. Like that's not mandatory, and a lot of countries don't have air conditioning. They might not have plumbing. Like they might have drinking water, but they don't have a way to flush a toilet, for example. So this standard of living is going to indicate the life expectancy, and that's really related to medicine or access to proper medicine. But it also has a lot to do with sanitation. So if you're able to prevent the spread of diseases because of infrastructure, that is related to the standard of living. So wealthier countries are able to have a higher life expectancy. And this will be related to biodiversity because a higher life expectancy may impact the population of native species. So a higher population might have a negative impact on biodiversity of the surrounding environment. So what I would like you to do is respond to this check for understanding. And additionally, I want you to describe how standard of living influences life expectancy. I hope that this video was informative. I thank you for your attention, and I will see you soon.